Hello and welcome to everyone in the new session of learning on caching overview. So now let's see what we're going to learn on this session. So here we are having some learning objectives under which we're going to cover what is caching, types of caching patterns, caching system, cache steps, and cache fetch flow behavior. Along with that, we will be touching upon outcome caching. So now let's see what is caching. Basically, data caching is a process of keeping a duplicate of data in a special storage area called data cache for quick access and regular use. This method stores the data in a cache rather than in a main file storage system to streamline retrieval and for easy accesses. Caching significantly boosts performance. So, this is one of the benefits of the cache. And through the Flow or Designer Studio, users can engage with the cached information in the interactive manner. Comes under the another benefit of the cache. Now let's go ahead and touch upon the types of caching. We are basically having two types of caching. One is bespoke caching and another is outcome caching. First, see what is bespoke caching. So, bespoke caching tailors the data caching experience to meet the unique requirement of users. It involves deliberate strategy of managing bespoke data caches, where the data items are added to the cache following the specific steps and methodologies at the memory they are needed by the user. Basically, this approach employs a strategic save and fetch pattern that makes the intentional use of the cache for optimal efficiency. User can interact with the system to ensure that the data they need is available on demand precisely whenever they need it. Now, if I talk about outcome caching, so caching is a method that operates based on the result of one or more steps. It is basically used up so that it doesn't need distinct caching actions. So when the data is saved in the cache, it is kept there and predetermined duration. So when the data is saved in the cache, it's kept there for predetermined duration, controlled by cache time span setting. This setting becomes available once the outcome cache is linked to a step. So this caching technique is especially useful for the scenarios that demands rapid data retrieval or when the user need fast access to a copy of flow result. Now, if we see the comparison of both the types of caching, now if we see the purpose of both of the cachings, so the purpose of using bespoke caching when you need customized caching tailored to a user need, whereas we use outcome caching when caching needs based upon the outcome parts of the step. If we talk about the management approach, it is managed intentionally using specific steps and methodologies. Whereas in the outcome caching, there is no specific caching steps it's required. Outcome paths determine caching. For the data storage, in the bespoke caching, data items added to a cache as per the need. Whereas in the outcome caching, data saved to cache based upon outcome steps. If we talk about the retrieval mechanism in bespoke caching, there is a key-based retrieval using put in cache and get from cache flow steps. Whereas in outcome caching, retrieval based on the cache outcome without additional steps. In the bespoke caching, cache time span is not time bounded. So here, data remains until explicitly cleared or managed. Whereas in outcome caching, data is stored for a set period via cache time span property. So where we can use the bespoke caching, so use case is custom scenarios where specific data needs to be cached. So where we can use the outcome caching, it's for the scenarios where we need quick fetch or when the user want a copy of flow's outcome. So how our flow designer is supporting the bespoke caching? It is just giving us additional steps available for caching management, whereas for outcome caching, there is no specific caching steps required and the automatic outcome caching is done by flow designer. Now we move ahead and just look on the caching patterns. Basically, there are two caching patterns. One is just in time or called JIT caching, and another one is prime the pump caching. So if we talk about the just-in-time caching, it is ideal strategy for clustered server setups. It's designed to incrementally fill the cache one server node at a time, which promotes resource efficiency. The data is stored in the cache just when it's needed, which minimizes the initial burden on the cache system. For initiating caching, we have to adjust our caching framework to start storing data as soon as requires and receives. For initiating the caching, in the just-in-time caching system, we have to adjust our caching framework to start storing data as soon as requests are received. For managing the memory, we need to set up rules for cache eviction to handle memory consumption smartly. For the best practice, we recommend to optimal your environment, you opt for JIT caching in environments with extensive server clusters. For the performance tracking, you just keep an eye on the frequency of cache hits and tweak the cache dimensions to fit. For scaling up, think about adopting distributed caching mechanism. Now let's see how just-in-time caching work. So in just-in-time caching flow, here we have used get from cache step, put in cache step, and empty rule. So here what is happening, the flow will check the data in cache and then run through is empty role or is null role. So if the data is not in cache, it will be added from the put in cache step and then let's go to end step. But if with the help of getting from cache step, it fed some data and into the rule, if it checks that output is not null, so it will be directly go to the end step. And by saying that, okay, there is some data into the cache. So prime the pump approach can strain the original database during flow execution as it requires transferring substantial data into the cache. As soon as the server is activated, this technique initiates the loading of cache data to promptly fill out necessary forms and data structures. For server clusters running over version 8.3 or earlier, it's essential to implement a system that enables cache functionality across the cluster network. Now, if we talk about prime the pump caching, basically in this method, data from cache loaded as soon as the server comes online to pre-fill the desired form, data structures, etc. The issue with prime the pump is that it burdens the origin database when the flow runs and all the data needs to be transferred into the cache. If we talk about the usability or the version consideration for the prime, the pump caching, the versions 8.3 and below in the cluster server environment, a system will need to be implemented to allow the cache to work across the clusters. The best recommendation is to build a scheduled job that is set to run at startup or a startup job when the service comes online. This will be keeping the cache loading service hits from the happening at runtime. Now let's see about caching systems. So here is one of the caching system which was used during the version 7 and below multi-server versions. So here, the parent record travel between the decision database and the decisions application via the ORM within the application server. So the record is saved to cache and events are triggered to keep the cache between server in the sync. In the caching, version 7 and below, which was multi-server systems, cache steps influence the local cache. Basically, in the clustered server environment, each cache server has its own distinct caches. Servers store a separate version of the cache objects locally. And also, server communicates through events to clear and refresh the cache objects. Now let's see the caching system which has been followed during version 8 and below, which were single servers. So the decisions application server has a local cache that is different than the databases. Using the various cache steps that affects this cache. Now let's look upon the caching system which we are using from version 8.3 to the current version of the decisions. As, as of version 8.3, caching is handled by Redis cache and not locally per server as in prior versions. So basically, local cache is still available, but it is not the default location to store the cache. Now let's look upon the cache steps. With the cache steps, user can store and retrieve data values in the memory for defined time. Basically, in decisions, there's ability to define different types of cache while trying to store some values in the cache. Define an instance of the cache type, and a key to access the current value. Here are some of the cache steps which we are having. First of all is put in cache. If there is nothing inside the cache, we use put in cache to insert the data or to put the data into the cache. If we are already having the data into the cache, if we want to see, so we use get from cache step. If you want to add one or more items into the cache, we can use it adding multiple items to the cache. Clear cache step is well versed for every one of you. If you want to clear the information from the cache, we use the clear cache step. Another step that we do have that is called key exists in cache. So it basically checks if the instance of the cache contains a key or not. Next, we are having put in cache, but this is for generate key type. So basically what it does, it allows a user to put a value in the cache to generate and out a key to access the particular value. Another last step that we do have that is remove key from cache. So basically it removes the key value from the cache instance. So next we move ahead towards the cache fetch flow behavior. So the flow behavior can be used to fill the cache in which data that needs to be kept for a certain period of time. Now I just quickly hop into my studio and walk you through with the whole process of cache fetch flow behavior with the help of one example. So here we are having our studio. So first of all, what we'll be doing, we'll be just directly going ahead into the designer project and create a flow from the action bar. And I'll just give it a name. Cache fetch flow and create. Now I just directly go ahead and into my properties. And under my properties, I am having the settings. Under settings, here is a behavior type. For this behavior type, I want it to fetch my cache values. So this flow behavior should be able to catch my cache values. So I'll just go ahead and change its type to system cache fetch flow, fetch behavior. System cache fetch behavior. As soon as I'll be choosing the system cache fetch behavior, it will be giving me two end steps. So system cache fetch behavior will be giving me two end step. One end step which will be ending up with my no cache value, and one end step which will be ending up with my cache values. Now let's suppose I need to get my some data. I just directly go my internet services and I want to fetch my some data. So getting all my data. And here the cache value will be picking my all data. Okay. Now I just go ahead and say save to it. After getting my all data, I have to define the cache type. So for defining the cache type, we'll go to systems. Under systems, we do have administration. Under administration, we have cache. As soon as we'll go to cache, we are having some already predefined cache definitions. But to make our own definition, let's suppose I want to make a time cache definition. So I'll just go ahead to the add option, and under the drop down, I can choose my time cache definition. I just go ahead and fill the cache using the flow. So what it will do for me, it will be just giving me option to pick the cache will flow. So remember that we have created one flow to get all the values. So here I'm just choosing my flow to get all the values from my account or the email addresses precisely. As soon as we just go ahead and now we just give the name. My time definition. Okay. And here I want to check on interval time span of 10 minutes, and it should run within 3 minutes. Let's say save. I just go back to my flow. So here, if I go into my flow, here I got to know, like although I have getting all my data from my account, but here I just choose get all the outputs. But here in this output of all the accounts, I can be having names, phone numbers, email addresses, departments, manager. So specifically what I want to get from the I want to get the data from it. I want only the email addresses. So I just go ahead and choose all email address, say done, say save, and close, close, close. Okay. Now we have created a flow to get the data from our the system, and we have also defined the cache. So this is my cache, right? Now, what next I have to do? So after defining the cache, After defining the cache definition, I just quickly go ahead and create a flow, which will be just giving me the information, whatever I have pushed in to that definition. So get the cache info. Say create. So here I'll just go into my systems. Under my system, I'm able to see my caching. So inside my caching, I am having multiple options. So add item to the list, like in caching, list type clear from cache, list type get from cache. So what we need to use here, as we are having multiple email addresses, not a single one. So we want to get from the cache. Directly go ahead and we drag and drop. And here we go. Now we just give the cache instance name, say email. The email addresses and cache type. Do you remember what is our cache type? That is my time definition cache. And what gonna be my key? So I just put it constant as email and say save. So here, if I just go ahead and say debug, it start debugging. And here we go. We can just see the data. Here we can see that we are getting all our information regarding the same. So this is how we can just go ahead and set the cache fetch flow behavior and use it from our flow design. So if we talk about the outcome caching, so in contrast to bespoke caching where flow steps, outcome caching allows user to store information on the output or outcome step. Rather than creating a copy of long-term use, outcome caches can be configured on hold onto stored data for set amount of time. Outcome caching is particularly useful for users that may need quickly fetch or make copies of the flow data easily accessible for such scenarios or the use cases like table integration or authenticating a token. Because the cache output is tied to a specific step, it is extremely useful for steps that are resource intensive and are part of flows that have high volume of traffic. As we are having different use cases for outcome caching, we do have some limitations hand in hand for the same. Due to the nature of caching outcome of step, information that is cached from the step cannot be fetched via cache from cache step. As a result, this cache data cannot be used outside of the flow for further evaluation or retrieval purposes and can only exist for set cache time spent. To access the data outside of the origin flow, users may need to create a cache definition and adjust its configuration. Also, the user may also need to write time cache definition to access the particular data. So yeah, that's it from my side for this particular session. Thank you so much. Happy learning.